my project. It's about synthetic data use in prediction models. So to start, who I am, my name is Cody Tangon. I'm a computer and data science major, and I just started minoring in public health. I'm starting my junior year at Chaminade, and a few things about me. I was born and raised in Oahu, and then some people say I'm addicted to energy drinks, but the energy drinks are addicted to me. What I like about computer and data science is the dopamine hit that comes after I get no errors in my code. And then this is a little picture of me, the only picture I have in my phone of me getting gifted a Ninja Turtles mask and an Among Us plushie during my graduation. So why this program and why this project? For this program, I wanted to do a project independently to build confidence in myself and prove that I know what I'm doing while trying to figure out something that I'm passionate about and want to pursue in the future. And then I wanted to do this project simply because I was curious about how synthetic data works and how it's created. And then the data set I chose was a lung cancer data set. And I chose it because I want to pursue a medical field. Oh, I messed that up. Medical field career after college. But being a doctor was too hard, so I just chose computer and data science. And then I already had a linear regression prediction model made, so I just wanted to make one for classification and see how that worked out. So the problem in the data, the question that I originally asked was, can synthetic data improve how a model predicts outcomes? And in medical research, data sets can be small and super imbalanced, leaving small sample sizes of different types of data. So the problem with this is I built a prediction model that averaged 90% accuracy on this data set just by guessing that all the patients had cancer. And then this is the data set that I use. It's from Kaggle. I chose it because I wanted something easy to work with and that I didn't have to clean up too much. So this data set is just 309 rows of patient records. It has 16 columns and variables, basically just saying stuff like smoking and coughing, so symptoms and causes of lung cancer. And then the cancer to non-cancer patient ratio was 270 to 39. And then the main problem I had with this data was encoding the lung cancer column because it would change the column name from lung cancer to lung cancer yes without me knowing. And an error would pop up because I wasn't using the correct column name in my model. So how I did it, I created the synthetic data using independent feature rate sampling. So I created 618 balanced rows. So 50-50, 50% being cancer patients and 50% being non-cancer patients. And then for evaluation, I use accuracy, F1 and AUC ROC. The tools I used was just Jupyter on my laptop. I used Python and all that good stuff for data prep and then PyTorch for the model. And then the way I did my project was I created one model with real data only to get a baseline, a second model with only synthetic data to see how they compare, and then a third to evaluate how the synthetic data actually affects real data and interacts with it. And then this is what I built, a feed-forward network trained on synthetic and a small amount of real data to help with distribution shift. And then I tested the training on the remaining real data that I didn't use for testing. Then I used AUC as the main evaluation due to the imbalance in the data set. So yeah, so I originally wanted to do my model running and just have a video of it playing in the background, but that took like way too long. So I just uploaded it to GitHub and just scrolled through and had a screen recording. So I was splitting the trained data set here. This is the test data. And then this is just me encoding columns. And then I started building the model and training it. So I had trouble originally. I wanted to do an auto stop, which just stopped the model from training once it had a good model, but it was stopping too early. So I had to take it out and manually input it, which is why it just takes so long to run. So I just decided to do this. And then over here, I checked for overfitting. And I didn't know this at the time, but I could have just done a verification data set separately from my training and test data. But I didn't know that. And plus, I think after when I looked into it, my data set was just too small to split it another time. So I did loss curve to evaluate overfitting. And then this is the evaluation of the model. As you can see, the F1 and the AUC. And then this is just to make sure that the model was actually giving me the answers that I was looking for. So confusion matrix and stuff. And then what I found, the final model, the mixed model, performed the best. It gave me the best results. It had a AUC of 0.97, which means that 70% of the time, or 97% of the time, the model was able to differentiate between cancer and non-cancer. And then the 85% accuracy tells me that the model was actually working and it wasn't just guessing one answer all every single time. So what I learned from all this is that synthetic data is kind of complicated to work with. You have to plan around certain things because when creating synthetic data, it can have different averages to the real data. So using it on its own wouldn't be ideal. I also have to plan better. When I started this project, I knew what I wanted to do, but I had no idea how I was going to get the results until halfway through. So it took me a day or two to figure out how to actually evaluate the model and put it together. And then I started tunnel visioning on accuracy on the final model instead of whether the synthetic data was actually affecting uh, the model or not. So yeah. So where I'm going, next steps and thank yous. Uh, the project could have been conducted better with a bigger data set, but I just wasn't able to find anything that would have helped. Uh, I could include a validation data set next time instead of manually testing for the overfitting, which would have probably helped with training and stuff. I can improve the synthetic data set. Uh, I chose the easiest way to make the data set because this is the first time I'm doing this and I wanted to just see how it worked and stuff. And then I figured out what I wanted to do after college. I want to be a healthcare data scientist. So yeah, thank you to all my mentors. This program, it really helped me a lot. I think it helped me gain the confidence that I needed to try new things and really, I don't know, what's it called? Like pursue things I normally wouldn't. And then I want to give a thanks to Dr. Stokes, Dr. Cleveland, and Shivani for allowing me to have the chance and running this program. Yeah. Any questions?
Very nice. It's quite the learning arc you went through. That's amazing. Are
Thank you. Thank you.
there any questions?
I have a question.
Yeah. What's up?
For you, Cody, I was curious, do you think with the implementation of synthetic data, do you think this type of model would work in like all types of healthcare, like surveillance or I guess like detection?
I only tried it with like value-based data, so I don't know how it would work with CT scans and all that imaging stuff, but I think it would be pretty effective in, yeah, most cases.
Okay, cool. Thank you.
No problem.
You have any other questions?
Yeah, I have a question. From your the database that when you use the app, do you have any problem like are you in the computer or are you using in the team?
I'm just using my laptop.
Yeah. Is there a problem with the big data like the computer
Um,
slowing down or something?
I think it just depends on how big the data set you're working with is, because it takes For the first two models that I built, it didn't take a while, but when I added them all together, it took like 5 minutes to run. So it just depends on how much columns and rows you have.
So 5 minutes to run. Okay, that's fine.
Thank you. Okay. I think we'll have Natalie next. Thank you.